So now let's see what we have learned. We have learned branch if equal, branch if not equal, how to represent this branch if equal, branch if not equal by using the assembly language, and how to represent that by using the machine language. And in machine language, we're using I format, and in immediate field is and the result is equal to PC plus 4. No, the relationship between immediate field and the real memory address of the instruction is label L, or the other label is equal to immediate field times 4 plus PC plus 4. So now let's try to look into another question, because until now we only talk about the condition for the conditional branch of equal, conditional decision making is only equality, right? Branch of equal means whether that the two source operands are equal, or branch of not equal is whether the source operands are not equal. But how about we try to consider more conditions? How about talk about whether large or equal, whether less or equal, whether large or whether less, right? Those things we definitely cannot directly represent by this condition by using branch of equal, branch of not equal. So in order to achieve this goal, but rather than create new instructions, new conditional decision-making instructions to represent or include those conditions, we introduce another instruction which called set unless then, and we're using set unless then to work together with branch equal or branch not equal in order to represent the conditional decision making, including the conditions of one of these four. Let me say one more time. So until now, branch of equal, branch not equal is effectively to represent the conditional decision making. However, the condition we talk about here is only equality, right? Equal or not equal. So there also has other type of condition, right? For example, larger or equal, large or less, right? And for the MIPS32, we now create the new branch instructions by including these four conditions. Instead, we introduce another instruction called set unless then, and let this instruction to work together with branch if equal, branch if not equal in order to achieve the conditional decision making by using one of these four conditions. So first, I want to introduce what is a set unless then. From the name, you can see what this means is set if less than, right? So basically, first, the operation code set unless then is SLT. So basically, is if S0 less than S1, I will set T0 as 1. Otherwise, T0 will be set to be 0. Let me say one more time. Set unless then has the notation of the operation as SLT, right? Set on less than. And then I will compare the two source operands, T1, T2. If the first source operand less than second source operand, I will set the destination operand, which is, let's say, T0, to be 1. Otherwise, T0 will be 0. Say one more time. If T1 less than T2, I will set T0 equal to 1. Otherwise, T0 will be equal to 0. Okay, that is a set unless then. So by doing that, we are able to work together with branch equal or branch not equal to realize that the four additional conditional decision making. But before that, I want to talk about how we represent this set unless then by using machine language. What kind of format we need to use? I want to pause here to think a little bit. And then you can continue. What I want to say is the set unless then we're using R format. The reason is this has a very standard format for the R format's assembly language, right? All the operation, if you all the operation which can be represented by R format will have the assembly language with this kind of format. The operation notation, destination, followed by two source, right? That's why actually set unless then using R format. R format we know has a 6 segment, right? First, always 0, which is operation code. The last segment is a function code. Here, set on lesson has a function code as 42, so I put 42 here. And because this one is now shift left logic or shift right logic, therefore shift amount, this segment will be 0. And then these three segments will be RS, RT, RD. Therefore, RS is S0, has the index 16. As RT is S1, has the index 17. RD is T0, which has an index of 8. Therefore, I can represent this assembly language by using this sequence of decimal number. Again, we said this is not the final representation, right? For final representation, you have to use in the sequence of 32 binary number. But it's easy to achieve that from this sequence of decimal number by convert the individual segments value based on the how many number of bits assigned to the segment. So there is an alternative format compared with set on lesson. For example, set on lesson immediate basically is one of the source operand is a constant. So I will use set on lesson immediate. For example, this one represents if S0 less than 25, T0 will be 1, otherwise T0 will be 0. And the set on lesson unsigned basically means the both source operand and destination operand are unsigned value. And set on lesson immediate unsigned means all the values are unsigned value, basically non-negative value, and one of the source operand will be constant. Okay. So here, this example just show how important we need to pay attention to whether it's a set on lesson or set on lesson unsigned, because the value will be totally different. Just the example as following. I know S0 is represented by this way, S1 represents this way, okay? If I try to use set on lesson, we know S0 actually is a negative value because the sign bit is 1. And if you convert this value into a decimal number, actually that is negative 1. So of course, negative value is less than the positive value, therefore T0 will be assigned as 1 because this condition satisfied. However, if I treat this comparison as a set on lesson unsigned, so in that way I treat S0 as 1, both non-negative or both unsigned value, then S0 will be a very large positive value. By doing so, the less this condition does not satisfy, right? So S0 actually larger than S1 rather than less than S1. Therefore, in this case, at T0, this destination value actually assigned as 0. Right? You can see by doing that, you really need careful whether it's set on lesson or set on lesson unsigned. In other words, whether you treat the source operand as an unsigned value or signed value. Okay? Because the result can be different. So now let's go back to the, what we said before. We said, right, instead of creating new instructions, we're using a set on lesson to work together with branch equal, branch not equal, in order to realize that 4 conditions: less than, less or equal to, greater than or greater or equal to, right? So here I want to mention is, although we said official instruction set does not include other branch instructions rather than branch equal, branch not equal. However, it still can represent the other branch instruction which are pseudocode. Pseudocode basically means pseudo instructions. What means pseudo instruction? Pseudo instruction means those instruction is not included like following. It's not included in the official instruction set. However, a sampler can understand those pseudo instruction and be able to translate the pseudo instruction into the re-representation of the set of official instruction. Let me see one more time. So set on lesson, set or equal to, branch if lesson, branch if less or equal to, branch if greater than, branch if greater or equal to. Those instructions are not included in the official instruction. Therefore, they are considered as a pseudo instruction because the assembly language can understand that and translate that into the regular official instructions. Okay, so now let's try to say how I can use the official instruction set on lesson, branch if equal, branch if not equal, to represent this branch if lesson. I want you to think about it and try to finish that by yourself, and the next class we will continue to talk about it.